Hello everyone. You might be a second year student or engineering student who's just interested in studying about AI, always been fascinated about how AI works, how to pivot into AI world, how to become a AI engineer to be specific, right? Because you might have heard a lot of fuss from your class, from your friends, talking about this new app, new chatbot which is released, which can do a lot of work. You might have heard a lot of mentions about the work of AI by your professors in class. And if you go on internet, there's a lot of fuzz of how to pivot your career as a AI engineer, right? And in this video, the goal is to help a person who don't know anything about AI, or specific, like he's just starting out his career and he don't know how to become a AI engineer or pivot into the part of artificial intelligence. So this video is to help that person who's just starting off his career, who's just starting off his college days and wanna utilize most of the times in it. So this is about it. In this video, we're gonna cover all of that. So with that being said, let's start without any further ado. I have my notes along with me. I have my whiteboard here, so I'll be speaking and talking to you guys, okay? So the first and foremost thing you need to understand is that there are some things which you need to have a good understanding before you pivot into the world of AI. And if I specifically talk, AI is segregated into two parts, which we will discuss in detail in few minutes. But AI is segregated into two main parts. One is purely research-based AI, where we do a lot of bunch of math, right? A lot of complex differential calculus, integration, a lot of stuff comes in, right? And another part of AI is product building side, where we use the existing AI products to build solutions for real world problems. So we will see, but the first and foremost thing is people think that whenever they wanna, let me zoom the screen, and people think that whenever they wanna pivot into the world of AI, it needs a lot of math, it needs a lot of understanding about complex research topics of machine learning. But in fact, if I specifically talk about the product building side of AI, which we are focused on this video, like there are some tools and technologies which we use, right? So to understand these tools and technologies to build products for AI applications, like building LLM application or building platforms for healthcare or law assistant or any real world solutions using AI, you need to have some basic understanding of technology. So our roadmap will start from the first and foremost thing, which is understanding of technology. What type of technology do we understand, right? Do we need to understand the framework of AI in a little bit good way? Is that the first thing is understand how web technologies and mobile work, right? So here comes the understanding of web development and mobile development. Jabir, I'm not interested in web development. I don't want to do web development, right? I don't want to learn HTML, CSS, and all that. I have been doing that from first year. Now I'm in my second year. I want to start something new, something fresh. Why I'm telling you this, that web development is really important, is because it gives you an understanding of how browser works, how internet works, how mobile apps actually work. So when you have good enough understanding of HTML, CSS, JavaScript, very boring stuff, everybody talks about it, and little bit of backend. If we are talking about one stack, then in this we'll have database knowledge of MongoDB, or you can go with SQL and Node.js. So when you have good enough understanding of web application, you will understand how the internet works, how you can build products for internet. Okay, so this will be the first and foremost thing. Have a not in-depth, you don't need in-depth understanding of anything in development to be specific, but have a overall understanding of how things works, what a API is. API is gonna play a lot of important role whenever you build AI products. So API is really important. I'll talk about it, but the first and foremost is understanding technology. It can be a mobile technology, it can be web the technologies which I mentioned just now. So this is the first and foremost thing. Now, if I talk about AI, right? I just mentioned now that AI is divided into two segments, right? The first segment is like complete in-depth research-based AI. And here we only talk about ML algorithms, we talk about research-oriented math, right? Research-oriented math of yeah, like we have calculus, we have differential equations, we have probability, like in-depth understanding of mathematical concepts. I hope I'm recording. Yeah, I'm recording. So these are the stuff where we solely focus on the research stuff, and this is more related to academia, right? If you're doing PhD of, or if you're learning, like going into the side of research through masters of PhD, then you will go into this path. Now we are in our bachelor's, we don't want to go in depth maths because we think math is something really complex, even though it's not. But what we want to do is that we want to build products without going into the complex side of math, without going into the building of neural networks, right? So if you want to understand how to build AI products without going into in-depth complex topic of mathematics like calculus and probability, then we have something called as AI building, right? This is the second segment, and here we call the people who comes under this umbrella as AI engineers, right? The people who build AI products without going into the depth with the existing tech stack. For example, let's say I have a AI LLM platform like ChatGPT, right? Using GPT, the products which we are building, right? I call myself as a AI engineer because I'm using the tech stack given to me and I'm building a real world solution for a corresponding problem using the existing tech stack without going in depth. So if we are doing that, then we call you as a AI engineer, right? As simple as that. So in this tutorial, in this roadmap, we're going to focus in this part, the second part, which is using the existing tech stack, how we are going to go and build AI products without even having complex understanding of math and physics. So let's begin our roadmap now. In roadmap, I would say that the first thing, as I talk about learning technology, right? Learning technology, and if I have to phrase it in a clear sense, understanding basics, right? And here, when I say understanding basics, the mandatory thing is you should understand Python, right? If you don't know anything programming, then I would suggest you that go and have understanding of what is function, what is a variable, understand each and every nuance of Python, right? Understand data structures. You don't have to go in depth. Again, as a AI engineer, you don't have to master anything, but you have to know how things behave. You have to handle the worst cases, right? If you can do that, if you are good enough with that, then you can consider yourself as a good enough AI engineer. So I would suggest that Python is very much mandatory. Learn Python, learn data structures and algorithms, learn variables and all that, right? So here I'm going to write it down. If you are noting along with me, then you can note it down: variables, data structures, not DSA, not complete DSA, but little understanding of what is a tree, what is a graph, what is a linked list, how hash map works, everything. Now after that, we have technology, right? And I will suggest you that mobile technology is very machine dependent, right? You need to have a powerful laptop, a powerful computer to run mobile applications and all that. So what I would suggest is use that key, start with web development, because you don't need a complex like computer to start web. So learn little bit of front end because you're gonna build apps, right? So to build apps, you need to have understanding of designing. You need to have understanding of what is a HTML page, what is a non-HTML page, Next.js, React. And if we learn Python, then we are gonna deploy our apps using Python only. I'll show you some platforms like Streamlit and all that. We'll talk about that in a few minutes, but yeah, understand front end and understand back end, right? So this is the thing. And the next thing you should understand is API. Jabir, you should have written this in basic foundation, right? In step one only, you you should have write it down. But why are you making it as a second point? Because like whatever the application we are gonna build, like let's say I'm building a AI based farming app, right? And in that I'm using ChatGPT. So if I'm using ChatGPT, what I'm doing is that I'm not downloading the entire model. I'm directly importing the API of GPT and using it. I'm building on top of the given API of OpenAI. So it is really important to understand how API works, right? What is API architecture? In API architecture, we have RESTful APIs, we have fast API, which is related to Python. Like this, we have different architectures, different formats that we use. So the first thing is understanding coding. Next one is understanding API, right? After that, the step 3 will be, I'm making it little clutter, but yeah, anyways, clutter is good. Sign of a geniusness. Yeah, the third thing is understanding math. So as I told you before, I might be writing spelling mistakes, so forgive me on that. But here you can see that I have divided AI engineer or AI, the person who works in AI, into two segments. One is complete researcher guy, and another one is an engineer who uses tech stack to build products. In research work, we go in depth of mathematics, but in AI engineering part, we don't go in depth of uh, research, in depth math, but I would suggest you that you should have a basic understanding of what is a vector, what is a function, right? Probabilities, how probabilities works, Bayesian theorem, and all little bit here and there, little stats. That's it, right? You don't have to go in depth, but have a, like, you might be studying, if you are a second year student, if you are a first year student, you might be studying math in your semester, right? And that math is more than enough to become a AI engineer. So have a good understanding of that, and after that I would suggest you that after having the understanding of basic technologies like Python and web development, after having a clear understanding of APIs and math, the fourth and foremost thing is understanding LLMs, or how LLM works, and modern AI. Modern AI. So let me tell you this, like if we are talking about LLMs, so the thing you should understand that LLM is a neural network, right? What is a neural network? Imagine neural network as a brain, right? It is a brain, but very simple, very easy to understand brain. It's not like human brain of course is very complex and it has a lot of functionalities, but imagine that neural network is like a single neuron. In our brain we have multiple neurons, right? Similarly we have a neuron, right? Now you have connected a bunch of neurons, and the work of neurons is that it will take a word, and based on the data you have provided it will predict the next word. That is the only work. Now when I'm saying that neural network, it predicts the next word, right? We say in AI terms, we are AI engineers now, so we call word as token, right? It predicts the next token. That is the only work of it. Now to predict the next token, for example, you have built a neural network, and in that neural network you have trained that neural network on a personal data of yours, right? So when you ask what is my name, it should answer you, your assistant should answer that your name is Jabir, right? It should understand what is the question and it should give you the corresponding next tokens. So taking the input and giving output. So in this process a lot of math happens, right? So what is happening under the hood is that a probability curve will comes up, and the word which has highest probability will become the next token. So this is how LLM works. LLMs are nothing but a basic probability distributions or normal distributions, and the word which has maximum probability will come next. and this distribution will get on continue uh, till we have the next word, right? Till we complete the query for a particular user. So this is how the in-depth understanding of LLM works, right? What is a neural network? Neural network is nothing but a model architecture where complex expressions are running, complex math is running, and the work of a neural network is to take a word and predict the next word. Simple, easy to understand. Now, like the important part is that key, you need to understand the working, but as a AI engineer, we will not go and directly implement the neural network by ourselves until and unless it is really need. We don't go and implement. What we do is that key, we have already pre-trained neural networks, pre-trained large language models like OpenAI's GPT or Anthropic Claude or DeepSeek models like R1. Open source models, again, like while talking about LLMs, there are three type of LLMs, right? Let me write it down here. We have three types of LLMs, right? The first type of LLM is completely proprietary models, right? And proprietary models are OpenAI, Anthropic. Like here, what they provide is that they just provide a API key, right? And we have to use this API key, whatever the query you wanna send, right? While building application, let's say I'm building a healthcare application, in that I'm using OpenAI API. So what will happen is that whenever a query comes in, I will send that query to GPT, which is OpenAI model, through this API. It acts as a like a third party platform which sends the query and receives the query as receives the answer for a particular query. So it acts as a middleman, right? So they don't tell you what is the code, how they implemented the model and all. This is first type of model, right? Proprietary model. We don't know how things works, we don't know what things works, what is going on under the hood. The second type of models is open source models, right? Open source models are completely trained neural networks, and for this open source models, like we have code available, we have the data set on which the neural networks are trained upon. So this is the second category of LLMs, right? And the example of open source models are Olama's model, right? We have uh, like Gwen's model. Gwen is a China company which produces a lot of open source models, right? And the third category is open weight model. What is this open weight? So what they tell you is that they will not provide you the code, they will not tell you the data set, but they will provide you the parameters, right? They'll make parameters open such that you can tweak and fine tune your models, right? So fine tuning, we'll talk about fine tuning, RAG and all that in few minutes, but using open weight models, you can fine tune the given model, right? And the example of fine tuning is DeepSeek, where DeepSeek is a open weight model. So these are the different three types of LLMs we have. Now, here comes the thing, right? We have the understanding of neural network, we know the different types of LLMs. Now, Jabir, like as AI engineers, what are we gonna do? What are the terminologies that we should know? The first and foremost terminology I would talk about is prompt engineering. What is prompt engineering? So here you need to understand that the model which you are using, for example, if I'm using Anthropic Claude model, it is fine-tuned. Most of the models are fine-tuned for coding. They are really good at coding, right? So if you are using that model for coding, then you will have maximum, or you can say most of the cases, good outputs, right? I hope I'm recording. Yeah, I'm recording, right? It will give you good outputs. Now, every model based on the data set they are trained on has some pros, has some cons, right? But you need to understand that LLMs are not good thinkers. They are good at predicting the next word. That's it. Now, to give the best word that can be generated, you need to give your output in a proper structured manner, right? So proper giving prompts, giving queries in a structured manner is nothing but prompt engineering. In that we have multiple categories like few short prompting, we have chain of thought, we have chain prompting, right? Chain of thought, let me write it completely. Chain of thought, we have chain prompting, right? Chain prompting and all this. We have different types of things. I'll try to make a separate lecture on prompt engineering, RAG, and agentic workflow fine-tuning. These four things very interesting as a AI engineer to see. But the main intent is that key in prompt engineering, we see that how we can create the perfect prompt such that we get maximum results. Right? This is the thing. Now, the second type of thing is that key when we talk specifically, AI engineering is RAG, right? Retrieval augmented generation. What is RAG? So okay, mic is keep on getting dropped anyways. So RAG, right? So RAG is basically you have a model, right, which is trained on internet data. Like if you take GPT is trained on internet data. They have crawled websites from 2007 to till now, and they have been like recrawling, ingesting new data every time. But if you are domain specific, for example, let's say I'm creating a platform for healthcare, right, or I'm creating a platform for law firms, right? So you cannot relay results on general data. You need external database, and here comes the RAG. So in RAG, what will happen is that key we will have, okay, so let me delete this. We will have a LLM, right? And we will set the context to that LLM. Like we will tell that model that you are a healthcare professional or act as a healthcare professional. Whatever the output you are generating, you have to generate in this format. We are like telling explicitly by a prompt that this should be the output, this should be the input, this will be the input, and all that, right? So input and output we are pre-defining early on, right? And we are telling explicitly that you are allowed to give output in this sense, and you're not allowed to go and search on your own data set. What you should do is that key we will give you a external knowledge base, and all the searching, all the retrieval will happen on this knowledge base. So this is known as RAG. I will try to make an in-depth video, right? We're just covering on top. We have talked about prompt engineering, we have talked about RAG and all that. So the next concept is fine-tuning, right? And this is important. Like for me as a person, RAG and fine-tuning are really, really important things. So what is the difference between RAG and fine-tuning? So I have told you, right? Fine-tuning, right? In RAG, what we do is that we will not go into the inner behavior of LLM. We use the existing LLM, whatever it is, use it. Tell it that you are not allowed to use your data set. You are allowed to use the external database which I'm going to provide you, right? Simple, easy to understand. But fine tuning, right, what we do is that key we fine tune, we give the context, and while giving the context we change the internal behavior of a model, right? We change the internal behavior of model. And how we gonna do that? By changing the parameters, right? By changing the existing parameters. I have talked about parameters in detail in our previous class of 2 hours lecture on deep dive of LLM. In that I have in detail explained what are parameters and all that. You can go and watch. But the thing is that key parameters allow you to change the internal behavior of a model, right? Here also sometimes we give external knowledge base, sometimes we don't give, but it is dependent on the problem statement, right? We give external knowledge base as well, right? It is dependent of what we are trying to create. This is the difference between prompt engineering, RAG, and fine tuning, right? Prompt engineering is nothing but you're not doing anything. You are just giving questions to your LLM and telling in a specific way that output should be this, input is this, and all that. But in RAG, along with the context, you are giving external knowledge base. And in fine tuning, along with the context, you're changing the, sorry, internal behavior of your model, right? So these are the things that we should do. So we have talked about 4 steps, which is understanding technologies, API, understanding math, understanding LLM. Now here comes the 5th thing, right? So let me go to the 5th thing, which is Let me go a little up. Yeah, advanced path, right? Advanced AI path. Now you have understood, you have math understanding, you have technology understanding, you have in-depth LLM understanding. Now in your condition right now, the condition you are in right now, you have four paths majorly. The paths are, okay, let me draw arrow. The paths are first pivoting completely into research, right? If you're really interested in research math part of AI, then I would suggest you directly go in research path, right? Research path of AI, and this is a long path, right? This is the longest path in all four, right? It might take you years to master, right? Here we talk about math, we talk about ML, we talk about algorithms, right? And this is not related to real world as such, right? We sit in labs, we sit in classrooms, we do a lot of things, right? This is complete research oriented path. And the second path is AI engineering, right? So what we do is that in AI engineering we have the understanding of how LLM works, how to use RAG, how to use this, all that. So here we learn new tools and we build applications on top of that. And here we have apps like Llama Index, LandGraph, right? So to build AI apps, we use these platforms, and to deploy your Python libraries, because this all things, all four are going to be in Python. We have platform like Gradio, we have platform like Streamlit, through which you can deploy web applications of Python very easily. You can use it. I'm providing all the links in the description, but yeah, you can go ahead and experiment with it. So this is the third path, and the this is the second path, and the third path is AI for startups, right? In AI for startups, what we do is that this is very similar to AI engineering path, but in engineering you are working for someone, you are working, or you're not focusing in real problem as such. But in AI research or AI startup, what we are doing is we are researching real world problems, right? We are researching and understanding real. If I talk about Indian local market, we are focusing on real problems of Indian market and trying to build solutions using the existing platforms we have. This is the path of a AI startup or AI founders. Like generally people also pivot in this path, and the last and foremost is MLOps, right? You might have heard about DevOps, right? Similarly, MLOps is basically handling the infrastructure, right? If I talk about agentic process, this is the fourth and last path, right? So if I talk about, sorry, so if I talk about agentic workflows, right? We have realized something that uh, agentic workflow is not dependent, or not, the technology is not much important, right? The tech stack, you might be using Python, or you might be using fast APIs or RESTful APIs, or you might be using Next.js. What we have learned over the years is that the technology which you are using is not important as such. What is important? The important part is the architecture, right? How you're putting system, how you're placing your tools in such a way that your system is producing best results. That is known as MLOps. In this, you will understand how to deploy your foundational models, your fine-tuned models, right? Your assistants, open source models. Like basically, we will learn in MLOps that how to deploy and host open models, right? How to manage your LLMs, how to manage your application, your AI application. So these are the four major pivotal points that you can make after doing all these four things, right? Which is having understanding of technology, API, understanding of basic math, understanding LLM works, right? After having, you have this four paths, and most people pivot in this path, right? They go in the path of AI engineering because it's most rewarding. But I would suggest that over the period of time, AI engineers will be more, because AI researcher will be more, because of the tools which we are having, right? We have Claude we have Codex. These platforms make development very easy. But anyways, it's not the point, right? We are focusing on AI engineering part. Now, the next part I would suggest is skill development. Now you have the understanding of how everything works. Now, what you do as an engineer is that key, see the real problem and build production level solution to it, right? So pick the hardest problem. This is my favorite thing to do all the time. Pick the biggest problem you can find and go beyond it. So when you do that, right, you will realize that you are understanding systems in detail, right? So it is important, right? Learn, learn, learn. See like a hawk, see like a eagle, right? See the core of problem. And I would suggest that more than coding nowadays, I know we are going a little bit apart, but the thing is system understanding is really important. The tech stack which we are going to use, the architecture which you are building, right? System thinking or system understanding is really, really important nowadays, right? What system, what architecture you're going to use, right? And the second is that debugging, right? This Claude Codex will build apps for you, but the problem is if they provide a thing, wrong thing, how you gonna tackle the problem, how you gonna debug your code. It is also really important. And the third part is that key, product communication, right? The products which you're going to build, you should be in a place where you can communicate your products. You should be very clear that I'm building this for this customer and this is the market for it. When you have a clear understanding, you'll get more rewards. And the fourth and foremost thing is uh, using AI platforms, right? Uh, Believe me when I say that AI has been evolving over a period of time very largely, right? AI is capable of building its next generation code. If it is in that condition, then think about the possibilities that we might have in future. So I would suggest you that go and interact with every other tool, right? So these are the things that you should focus on, right? System level thinking, debugging, product communication, and using every other AI platform, right? But it doesn't mean that you are just going beyond launches, right? Let me tell you what are the things you should avoid, right, as an engineer, right? To be specific, as an AI engineer, the thing you should avoid is deep understanding of thing because it consumes a lot of your time. You're not gonna you don't want that, to be specific, right? If you want that, then you will go in research path, right? So avoid going in depth and avoid not building, right? Most people just see tutorials, right? They just stop at tutorials. Don't do that, right? See tutorial right away, go and implement something. When you build, you will understand what is real, what is not. When you do, you will understand, right? And the next thing is uh, don't fall for trend. Jabir, you were just telling that go and interact with the new platforms, and now you're telling that don't fall for trends. So what I mean by this is that you might see a lot of LinkedIn post, Twitter post talking about new apps, this and that, clutter, right? If something is revolutionary, you will get to know by everyone. So focus on what is important, try to do what is important, right? So this is pretty much it. So I have completed my notes. Yeah, this is pretty much it. This is the complete roadmap that you should follow as a AI engineer, right? First of all, having understanding of technology, APIs, math, right? Understanding of LLMs in depth, pivoting what you want, what you don't want. And after that, I have talked about what skills you exactly need, what are the things you should avoid. So this is the overall roadmap that I would follow if I'm starting in as a student in second year in 2026, right? And I want to make long form content, very long form content to bore you guys because I know that I have been seeing my analytics for a while now and I have realized that my audience, my segment of audience, even though you guys are very small, very little to watch, nobody watch because I'm not consistent nowadays, but I have realized that the length that we watch is really good. My attention for classes is really good, even though I'm speaking a lot of time chunks, but you watch till end or you watch midway. Nowadays it's really rare because you see reels every now and then. But that is the one thing that I'm really proud about my audience, right? They stay for longer times. They crave intellectual content. And I try to be more consistent, even though I've been involved in thousands other things. But yeah, so this is the roadmap. I hope you got the links, and I will provide you the tutorials which I watch, right, personally, about Llama Index, Streamlit, Python deployment, everything in the comment section. You can go and watch it out. The most important thing is, I would say, is this implementation, right? You might see 20 minutes. This might be how many minutes? 25 minutes. I've been talking for 25 minutes, 30 minutes, right? You might see a lot of tutorial, but the most important part is going and implementing the things which you're gonna build. So I hope you have learned what is important, what is not, a complete clear mindset. So with that being said, I'll see you in the next one.